if we had to solve by graphing this equation, right, what it would mean is put it in the calculator on y equals, meaning graph the function y equals x squared minus 6x plus 8. And then what would you be looking for? Y-intercept. The x-intercepts. Okay? You're looking for how many times across the x-axis, what are the values? In this case, how many solutions do you see? It looks like there's 2 of them, 2 and 4. They both show up in the table of values. That's our answer. Okay? Right? If we had to solve the same this equation the same way, right? X squared minus 6x plus 9. I'm looking at the graph. How many zeros do you see? You know, it looks like just 1 0. It looks like it's at x equals 3. And that's confirmed right there. At x equals 3, y equals 0. But what do we know about that 0? Because the graph doesn't actually change sign after the 0. It goes back the same way. What does that tell you about the 0? No. It tells you that that factor is there an even number of times. It's got to be there twice. I mean, just factor this here. We could have done this by factoring easily enough. Right? If I would have factored this, I would have seen that this is x minus 3 squared, right? And because it's squared, that's why when x goes from less than 3 to more than 3, it doesn't change sign, because in either case it's going to be positive. So it's actually one number, right, 3, but it's there twice. So that accounts for both zeros. So remember, when you see a graph like that, you got to be thinking to yourself, that has to be there an even number of times. It could be 2 times, it could be 4 times. I mean, this one is a quadratic, so what's the most times it could be there? 2. It couldn't have been there 4 times, because there's only 2, could be at the most 2 real zeros. Okay. But what if we have an equation like this, that when we graph it in the calculator, it's a parabola that actually doesn't cross the x-axis, right? Well, at that point, you know, you don't have any real zeros. You know, up until this last lesson, we were only looking for real zeros, right? This is the point where we go back to, okay, remember the complex numbers, that there are times when we actually find zeros that are not real numbers. So let me, so no crossings of the x-axis means no real solutions, no real zeros. Okay, so in order to deal with that, we define something called, or we define the square root of -1 as an imaginary number, I. Okay, the I stands for imaginary. Okay, if you solve the quadratic formula, solve this same equation with the quadratic formula, right, then this is what it looks like. X equals negative, I got to do that again. -2 plus or minus the square root of -2 squared minus 4 times 1 times 5 divided by 2 times 1. Right? Simplify. Equals 2 plus or minus the square root of 4 minus 20, -16 over 2. Right, so now, -16, if you tried to take the square root, your calculator would say non-real solution. Right? But if we use this definition here, then the square root of -1 is I. That makes this whole thing 2 plus or minus 4i over 2, which is 1 plus or minus 2i. So by introducing this concept of imaginary number, we actually can find the last 2 zeros. They just don't happen to be real. They've got this imaginary quantity, the square root of -1, as part of the answer.